Good morning to one and all. My name is R. Joseph Paul, Assistant Professor, Department of Mathematics, SNS College of Engineering, Coimbatore. Today we are going to look into the operation of matrix. That is the second part we are going to take off. The last we are discussing about the types of matrix. So there we are discussing about equalities of matrix, adjoint of matrix, and the determinant of matrix. So once again, briefly we'll discuss about those matrix, the operations of the matrix. So the previous classes we are discussing about equalities of matrix. So here once again we'll come with determinant of matrix. To compute the inverse of a matrix, the determinant is required. Each square matrix A has a unit scalar value called the determinant of A. It's denoted by determinant A, or we'll say it as a mod A. We'll read it as determinant of A. If A, we are saying it as 1, 2, 6, 5. So it is a 2 by 2 matrix. When we find a determinant of this, we'll draw a two parallel lines. 1, 2, 6, 5. It should not be a square matrix. Always a determinant is defined as a two lines. We are talking about parallel lines. If you are marking it as a square bracket, then the notation is wrong. When we talk about determinant, we'll draw a parallel line. If A is equal to a square matrix, that is determinant of matrix of A is a single element 1, 1, then the determinant is denoted as the value of the element. That is, we are saying it as an element of that. Then the determinant of A is nothing but A11. If A is n by n, its determinant may be defined in terms of order n minus 1 or less than that, are called as the determinant of matrix. Minor matrix. If A is n by n matrix and one row and one column are deleted, then the resulting matrix is n minus 1 by n minus 1 submatrix. So when we defining a matrix, so the corresponding row and the corresponding columns are eliminated. That matrix we are saying it as a submatrix, or we'll say is a minor matrix. So the determinant of such a submatrix is called a minor matrix of A, and it is designed by Mij, where I and j corresponding to the deleted row or a column. Mij is a minor matrix of the element Aij in A. An example, a matrix A is given a 3 by 3 matrix. I need to find a minor matrix of A11. So the corresponding first row and the first column will be eliminated. So the minor matrix of the first row, that is the first element, is the determinant of A22, A23, A32 and A33. Each element in A has a minor. Deleting a first row and the first column of A, the determinant of the remaining 2 by 2 submatrix is known as a minor matrix of A11. Cofactor. The cofactor Cij of an element Aij, it's denoted as Cij. That is, we are going to define the cofactor of the corresponding row in column by taking minus 1 to the power I plus j of Mij. M, it's nothing but a minor matrix. When sum of a row number I and the column number j is even, then Cij is always positive. We'll have a positive minor matrix. When I plus j is odd, we'll come across with negative minor matrix. Cij is equal to minus Mij. So an example, it is given C11. Both are odd numbers. When we add, we'll have an even number. So minus 1 to the power any even number is going to be positive. So we'll have a positive minor number. When we come across with 1 is positive, that is 1, 2. So here we are saying 1 and 2. When we add, we have 3. So we are saying it's minor matrix. Minus 1 to the power 3, it's going to be always negative. Odd power is always negative. So we are saying minus 1 to the power, that is 1 plus 2 of M12. So it's going to be a negative minor matrix. Similarly, we are looking into C13. So we are saying into C13, it's nothing but when we add, we have an even power. So minus 1 to the power even, it's going to be positive M of 1, 3. So likewise, we are finding the determinant value. The determinant of an n by n matrix A can be defined as a determinant of A. That is nothing but by calculating its minor matrix. That is the first row's minor matrix we are defining. So the determinant A is therefore the sum of the product of the elements of the first row of A and their corresponding cofactors we are defining. The cofactor of the first row, it is defined as the determinant value. So this is the example of the determinant is given. So this is how we are going to calculate. Now we are talking about adjacent matrix. Adjacent matrix is nothing but it's A into adjoint of A into A, it's nothing but I we are saying. So what is adjoint of A? Adjoint of A, it's nothing but transpose of it. So adjoint will help us to find the inverse. A inverse is equal to adjoint of A by A. So this is how A into A inverse is equal to A inverse of A is I. So here similarly once again what we had discussed in the previous class. If the determinant value is 0, we'll have a singular matrix. If it is non-zero, we are saying it as a non-singular matrix. Thank you. We'll discuss the remaining properties of matrix in the next class.